Hello, in this video I will be performing a brief tutorial of the word embeddings or Word2Vec GUI in the NLP suite. This GUI allows you to map the words in your corpora into different clusters based on past similarities in topic and frequent associations. If given sufficient data, Word2Vec can make fairly accurate guesses about words' meanings and even classify text files by different topics. For this demonstration, I will be using the newspaper articles corpus, which is a collection of 6 different documents and located in the sample data folder of the NLP suite. Once you have your input and output set up, the first two options here allow us to decide whether or not to remove stop words and punctuation, such as determiners, possessive, pronouns, etc., and whether or not to lemmatize the words within the corpus. In this case, we will select both, as that will help combine words into their most basic values and help to improve the readability of our outputs. Next, we select the visualization option, allowing you to choose between various different methods of visualization. For this demonstration, we will plot the word vectors, and we'll plot them in 2D. The next widget allows you to perform word sense induction with the sliders on the right, setting the values for k-means minimum and maximum, the n-grams, and maximum number of keywords to be returned. For now, we'll leave these as the default values. Word sense induction is the problem of automatically identifying the different senses expressed by a word used in a collection of documents. For more information on this, please refer to the relevant tips file, Word sense induction. Here's the word sense induction tips file if you need to find more information. You may also input a dictionary file and use it to enter keywords which you are interested in conducting word sense induction on. For now, we'll leave this blank. Next, we can select word embeddings via BERT or Word2Vec with Gensum. While you can run both, there are some differences which you can find more information on in the tips file. Here's a tips file, word embeddings with BERT, and here we can review the differences between the two methods and other relevant information. Additionally, we can choose which training model architecture to use, with more information on these in the Word2Vec tips file. Here's the tips file, where you can find, among other things, some of the information about the two different model architectures. Once we select those, we can move on to setting the vector and window size and the minimum count. You can click the Help button to get more information on what they do. Now we can select Compute Word Distances to compute Euclidean distances and cosine similarity between words. Additionally, we can enter some keywords in if we are interested in looking at those specifically. Finally, we can run the GUI. Here are some results you can expect when running the word sense induction, word embeddings with BERT, and Word2Vec with Gensum widgets from this GUI. Here's what a sample output folder might look like when running those 3 tools. Let's first look at the word sense induction. As you can see, each of these folders corresponds to one of the 6 documents in the corpus, with different outputs for different clusters. And this will look different for your corpus, but here's a general overview of what the word sense induction might look like. Next, let's look at the BERT output. So here we can see there are different Excel sheets and graphs generated with the CSV files and 2 HTML files which will lead you to the visual clusterization of the words in corpus. Here's an example Excel output showing the frequency distribution of cosine similarities. So on the x-axis we have cosine similarity and frequencies on the y-axis. Here's the output from the HTML files. They display the same visualization, but one shows the words without hovering over the points, whereas the other does not. Each point represents a different word in the corpus, and closer words are more closely related. To find more specific information, you can select a window to zoom in and analyze smaller sections of the graph. Finally, let's explore the output from Jensen. Again, we find some Excel graphs and an HTML file visualization. Here is the Excel file showing the frequency distribution of cosine similarities, with cosine similarity on the x-axis and the frequency on the y-axis. And here is the HTML visualization, which is very similar to the previous graphs, but with some differences. You can explore these as you apply this GUI to your own corpus. Again, each dot is a different word, and we can zoom in to look at a smaller section of the graph. I hope this clears up any questions you may have had and clearly demonstrates how to use the Word2Vec GUI. Of course, there are other files we may not have gone over, and your output will vary based on your corpus. I highly encourage you to experiment with this GUI yourself, and I hope it proves to be useful.